Very good morning to one and all. First of all, I welcome all of you for our GATE coaching conducted by our SA Engineering College. Assistant Professor, Department of Artificial Intelligence and Data Science, and I am going to deal with the subject data structures. Today, our topic in data structures will be shortest path algorithm. In shortest path, data structures, you all know, data structure is a very important subject when we consider for the GATE coaching. So, because data structure, it involves a lot of analytical solutions which can be dealt with the problem solutions and also finding the answers for the problems. Okay, so data structure is the heart of the thing which is to be considered for the GATE classes. Okay, so today we are going to discuss about the shortest path algorithm. Shortest path in the sense that you are going to find a distance from first node to the last node, which will be the shortest path and which you can provide you the minimum distance and also the minimum time reduction. Okay, so for that we are taking into consideration the shortest path of the Dijkstra's algorithm. Okay, so there are various algorithms we will be dealing with the shortest path. So in this case, the most of the questions are asked from the GATE syllabus in Dijkstra's algorithm. So I am taking this topic Dijkstra algorithm for our GATE class. Okay, you can have the thing shortest path. Shortest path is nothing but the distance, the minimum distance from the node, from the first node to the source node, from the source node to the destination node. That is called the distance. That is minimum distance you have to take into consideration for finding the shortest path. Okay, so single source shortest path problem. So that is will be the major idea of Dijkstra's algorithm. You are going to consider the single source shortest path problem. It is nothing but the problem of finding the shortest path from the source to the destination. You will be knowing the tree structure and you will be knowing about the various nodes which will be used to connect things. Okay, so you have like a number of nodes can be used in the path and you have to find out the which will be the best distance, which will be the best path from the source to the destination. So you can take an example. Here, these are the applications where you can use the Dijkstra's algorithm in real time, in Google Map, in Ola Cabs, all the things you can see the implementation. Implementation in the sense the Google Map where you can find the distance from your source to the destination. Okay, so that is your one type of real-time application where your Dijkstra's algorithm is used. Okay, so before getting into the problem solving or before getting into the GATE questions, you should know what are the applications of Dijkstra's algorithm. Okay, so this is the example. You can see a map, a Google map where you can find the routing systems. Example is given. Routing is nothing but the distance. To go to the network, you will be having the port address with the corresponding port numbers, and each thing will be arranged in like this fashion, where you can see your desktop computer, port 1, port 2, port 3, port 4, like that. So all the things have been linked and you can find the distance. So this is the, you have to find out the distance which will be the best one in the case. Okay. Now we'll see what is this Dijkstra's algorithm. Dijkstra's algorithm basically a solution for a single path algorithm. It basically works on two things. One is directed, another is undirected graph. Directed graph is nothing but where you can have the distance between the two things. One is called the vertex, another one is called the edges. Okay, so vertex and edges will be form a graph. So that is the connecting the two nodes will be the vertex and the edges. Okay, so the distance will be given as a points where you can have the values. Okay, so that is directed and undirected graph. Already we discussed this directed and undirected graph in A-star algorithm in previous sessions also. Now we will see the input weighted graph G equal to E comma V and source vertex V, that all the edge weights are non-negative. So the main thing of Dijkstra's algorithms, all the things will be having non-negative edges. Okay, non-negative means that is a positive value. Weighted graph G equal to E comma V. Output length of the shortest path. So the output, the ultimate aim of this Dijkstra's algorithm, you have to find out the minimum distance. That is shortest path you have to find out. The algorithm computes each vertex for you and the distance from the vertex and the weight of the shortest path between the vertex and thing. The algorithm keeps track of set of vertices for which have been computed called the cloud C. Okay, so you will be putting the values, vertices and edges in a thing called cloud C, where you will be using the cloud to calculate the distance. Each vertex has a label D associated with it for every vertex and the approximation of distance between the vertex and U. The algorithm also computes D of U, which finds the shortest path. When a vertex is added to the cloud, you can use this cloud to find out the distance. So everything, the value will be stored in the cloud and you can use that cloud to find out the distance. So this is a sample code for Digitras where you can be using the minimum distance algorithm to find out the path. Okay, so for each vertex the distance will be calculated using the infinity value and also the distance. So distance is nothing but from the source node to the destination node. You can use that value and you can calculate the value using the infinity. Okay, so when the list is not empty, you can remove the vertex and find the minimum distance. And also you can have this thing with the neighboring nodes. You can calculate the distance of the thing using the neighbor node. Neighbor node is nothing but the adjacent node of the graph. So where you will be having the graph where you can have the adjacent node. Okay, if the distance is smaller, then you can calculate the final distance. Okay, you have to calculate it from starting node to each ending edges and you have to find out the distance. And based upon the distance, you can find out which is maximum and which is minimum. When you can take this consideration, the minimum distance will be taken into the account. Okay, so this is a sample code of Digitras where you have two vertices V1 and V2. Based upon the V1 and V2, you can calculate the distance and you can find the solution for this thing. Example. Now we can see an example how this Digitras algorithm plays a key role, and also we can find a question based upon this Digitras algorithm in GATE. Okay, so we take an example where you can have the following nodes A, B, C, D, E, F, G. It is arranged in a graphical fashion where you can have the values for each node. So distance is starting from the distance is called the source node and the ending the node is called the destination node. Where you can have the source node as 0 and the ending node each value will be given. So you can consider the distance of all vertices. But source will be the infinity. So this symbol is called as the infinity, where you can use this one. So A, B, C, D, E, F, G. Pick vertex in list with minimum distance. For each thing you will be given as values. A to B is 2, B to E is 10, and D to E 2, D to B 3, and A to D is 1, C to D is 2, and C to A is 4, and C to F is 5, and F to D is 8, and F to G is 1, and other things you will be considering the infinity. Okay, so this is a sample example. So initial thing you have to find out the initialization values. Okay. Example, update neighbors distance. From the first case, you can start with the source node where A will be the source and B will be the neighboring nodes. So first thing is you have to calculate the distance from A to B. The value given is 2. So when you add the value of A with B, you get the distance of A to B. 0 plus 2, 2. And D will be the minimum distance with the value 1. So you can take the consideration A, B, D, where A to B is 2 and A to D is 1. So the total distance of D is 1 and total distance of B is 2. So this is the case. First initialization, update the neighboring nodes. You have to update the neighboring nodes means when you take the A as the first node, then you can consider the opposite nodes as the neighboring nodes. The neighboring nodes we have to find out the values. You have to update the values. Okay. So A to B is 2 and A to D is 1 and B to D is 3 and C to D is 2 and C to A is 4. Like that all the neighboring nodes you have to update the values. Example, remove vertex minimum. You have to remove the vertex which has a minimum distance. Already I told in the algorithm itself, when you consider this thing, you have to remove the vertex which has a minimum distance. In this case, if you consider all the nodes, the minimum distance will be A to D is 1 and F to G is 1. So other things are you have more than 1. So that is the minimum distance is 1. Minimum distance here, D is the minimum distance which has a 1. We have to remove this D. Based upon this, you have to calculate the updated values. Update the neighboring nodes. So based upon this algorithm, you can calculate the distance C. C is calculated based upon the minimum distance 1. 1 plus 2 is 3. 1 plus 2. 1 plus 2 is C equal to 3. So if you add 1 plus 2, you get 3. So that is the distance of C. Next, you can calculate the distance of E based upon the value of D. 1 plus 2, again 3. Again, you can calculate the distance F. 1 plus 8. So if you take the D, 8 and F is 1. So 1 plus 8, 9. So that is the distance of F. Distance G is, you can calculate 1 plus 4. So that is the distance G. So this is the thing you have to consider for updating the neighboring nodes in order to find out the values of the distance. Okay. So pick vertex in list with the minimum distance B and update the neighbor. So minimum distance B, now 2 became the minimum distance. After the 1, D is 1 and F is 1. So you take the minimum distance B equal to 2. Okay. So distance D not updated since D is already known as distance, and distance E is not updated, it is larger. Because E is larger, you can see the value. E is 3. Okay. So this is the next thing. Pick vertex list with the minimum distance E and update the neighbors. Now if you take E as minimum, 3 will be the minimum value. You can take the 3 and you can update the next neighboring nodes. Okay. So if you take a 3, no updating because other nodes values are updated. So pick vertex with the minimum distance C and update the neighbors. Now if you take C as a minimum distance, you can update the neighboring nodes. Neighboring node is F. So 3 plus 5, you get 8. So now 8 is the value of F. So it is got through the updating the value of C with F. C is 3 and F is 5. 3 plus 5 is 8. Next, you have to pick the vertex list minimum distance G. Now, if you take G as a minimum distance, G is 5. You can take the G as 5 and update the neighboring nodes as F. So, distance F equal to minimum 8, 5 plus 1. So, 6. 6 will be the distance of F. It is the previous distance. Okay. So in this way you find all the values of the corresponding neighboring nodes and you can update the thing. This is called as the Digital algorithm, where all the nodes are updated with the corresponding value. With A is the starting node, A equal to 0, B equal to 2, E equal to 3, G equal to 5, F equal to 6 and C equal to 3 and D equal to 1. So this is the thing you have to take into consideration for Digital algorithm. Put pick vector starting S with the lowest cost F and update the neighbors. So this is one type of thing you have to consider. And another example also is given, where you have 5 nodes A, B, C, D and E with value 0 to B is 10, B to D is 2, B to C and C to B is 1 and 4, C to D is 8 and E to D is 7 and 9 and C to E is 2, where you can start with the neighboring nodes updating as usual what you saw in the previous example. You can update the neighboring nodes and you can find the distance. So if you take this question, A, B, C, D, A will be the minimum value where you can start the source node with 0, B is 10 and C is 3 and D is infinity and E is infinity. So first thing you have to take the starting source node S, A equal to A. Next thing is C equal to 3. So next minimum distance is 3. So C is equal to 3 and next thing is E is 5, so you can take S equal to A, C, E. So this is the first thing you have to consider the minimum distance. And next thing you have to update the neighboring nodes. Already I told you how to update the neighboring nodes in the previous example. The same thing you have to follow in this current example also. where you can update the values b equal to 7 and d equal to 11. So now if you take the next minimum distance a comma c comma e comma b, so b will be the 7. Next thing is if you update the value of e, next is the a comma c comma e comma b. So this is the way the algorithm goes. Finally you get the output a comma c comma e comma b comma d. So this is the value you got after the processing the nodes. So this is the one type of thing we have to consider. Again, next thing also you call as the cloud, where you can store the values of vertex and edges in the cloud. So this is a sample code of already previously I told with the graph G and vertices V, where you can update the values using this vertices. Time complexity is 0 of n square. So the time complexity very important in case of Digictor algorithm, because it is an algorithm which widely used in the shortest path finding. This is also mainly the main questions will come from Digictor algorithm. As a students you can make a note of it. The main thing is you have to know the key concept of Digictor algorithm, that is finding the node with the shortest distance, and also you have to save the time. Very important thing is time complexity. When you consider the vertex and also the loops and edges, you have to find out the minimum distance that can be calculated using the total time. Total time equal to v square plus e equal to iv square. So that is O of n square, that will be the time complexity which can be used for calculating. So now students, you can get into the gate question. I am going to solve a question which will be the complex one. Complex gate question. Consider the question. Consider the directed graph shown in the figure below. There are multiple shortest paths between the vertices S and T. Which one will be reported by the Digictor shortest path algorithm? Assume that in any iteration the shortest path of the vertex V is updated only when a strictly shorter path to V is discovered. So now you consider this graph where you will be having various path between S and T. The starting node will be the S and the ending node will be the T. So if you start with the S, A, C, E, G, T, D, F, D. So these are the various nodes and various path is given with the values. Now we have to find out the solution which is the shortest path among this graph. Okay. So now the values are given from S to A is 4, A to C is 1, C to E is 1, E to G is 2, E to G is 2, again G to D is T is 3, and T to E is 4, T to D is 3, and F to D is 5, and B to D is 4, and D to S is 3, and B to S is 3, and S to D is 7, and D is having various combinations with other nodes like D to B is 4, D to S is 7, D to C is 3, and D to E is 1. So this is a complex graph which is given to find out the shortest distance. So now we will have various solutions. So the first solution is SDT, second solution is SBDT, SACDT and SACET. So these are the various options given. For each option you have to find out the distance. For the first thing is SDT, you get the summation, that is after adding the neighboring nodes you get 10. And next thing is SBT, again this also you will get the value 10. Again SACDT is also you are getting the value 11. So it is greater than when compared to A and B. Based upon the summation of the nodes adding you will get the value, and SACT also you will get the value 10. So the best option is D, because it is the neighboring shortest distance which covers from the source to the destination. So SACET will have the value 10 after adding the previous node. SACET, that is 4 plus 1 plus 1, 6 plus 4, 10. So SACET. So this is the final solution for that value which is asked to find out the shortest distance. Okay. This type of questions will get in the gate in previous years also, and coming years the same thing will be repeated. Thank you.